Hi everyone, this is Molindronica from 4th year CSE. Today we're going to see about a second exercise in data mining, which is about decision tree. A decision tree is a decision support tool that uses a tree-like graph or a model of decisions and their possible consequences, which includes the chance event, resource cost, and the utility. It uses some particular algorithms to display, and the most admirable thing in this decision tree is that it is very simple to understand and interact with people. People can understand this decision tree model once after a brief explanation, and it can have values which is a little hard with data and allows the addition of new possible scenarios and helps in determining the worst and the best part for the expected value, and it can combine with other decision techniques. The one of the most important and specific technique in this decision tree model is pruning. Pruning is a technique in a machine learning that reduces the size of the decision tree by removing sections of the tree that provide little power to the classified instances. Pruning reduces the complexity of the final classifier and hence improves the predictive accuracy of the decision tree. So today we're going to see about the working model for this particular decision tree with RapidMiner. I'm going to choose my dataset from samples. I'm choosing the iris dataset. Once after choosing this iris dataset, I'm going in for choosing the operators. So here we choose this decision tree operator. Once after choosing the dataset and the operator, I'm going in for connection. After connecting it, the process is being processed and we get this decision tree. This decision tree is a very simple decision tree with few attributes. Here the root node is A3 and all the other nodes are classified accordingly with parent node and the leaf node. In this decision tree, each and every node has a particular if condition. Only if the condition is satisfied, it classifies the attributes accordingly. So if the attribute is classified by iris virginica or iris setosa, it's because of this if condition. It is a very simple decision tree. I'm going to show you a decision tree with more attributes. I'm going to choose some other dataset from sample. I'm choosing the Sona dataset. And once after the connections are done, I'm getting a really complex data decision tree for the dataset Sonar, which is a bit complex than the previous one. Here I have all those if conditions and the number of attributes are increased. Here the root node is attribute 11. And now I'm going to show how to use the discretized operator for this decision tree. Here we have many classifications like size, binning, frequency, user specification, and entropy. I'm going to go with discretized by frequency. Once after dragging it, I'm going in for connections. Here the connections are made and I'm going in for run. So here I get a really huge decision tree which has all those ranges. The main purpose of this discretized operator is that it shows the ranges for each and every attribute for the decision tree. So for validating a decision tree, I'm going to use the validation operator. I'm going to choose this X validation. So within this validation, we have two parts, training and testing. In the training part, I'm going to use this decision tree operator. So in the testing part, I'm going to use two more operators, which is apply model and the performance. Once after dragging in all the operators and going in for connections, once after the connections are made, going in for the process and connecting it. Here in this decision tree, we have specific parameters like maximal depth and pruning, confidence, etc. The maximal depth is given as 20 because the maximal depth cannot be increased, and if it is increased, the complexity of the decision tree will also increase. And here is the confidence, and by increasing this confidence, we can have a better accuracy in our decision tree. So I'm going in for run. So here we get accuracy of 62.12%, which is an average accuracy, and I have two classifications, which is rock and mine, and their respective accuracies. To increase this accuracy, I'm going in for discrete parameter again. I'm gonna add this discrete parameter. This discretized parameter gives us the effective view for the decision tree. Once after connecting it, I'm going in for run. So I get the accuracy for 72.10%, which has increased. So this is how the accuracy for a decision tree can be increased. And this is the overall view for the decision tree. Thank you.